Hi, this is another example of function composition. I have here a set of three functions. This one will be f of x, d of x, and h of x here. And I have two operations to realize here. Will be the compose of f of g of h of x, which, remember, this statement here is just a synonym for what is here, f of g of h of x. Now, let's get to business here. The first thing we have to do, we have to start with the deepest function here, which, or deepest statement here, would be this one here, and that's why I'm going to start here. In here, g of h of x here, that is to say, would be g of the value of h of x, which is in here, x plus 3. That is, I'm saying that I'm going to substitute the x plus 3 in every x of g. So I'm going to do it in here too. I'm going to open this parenthesis. I'm going to place in here the x plus 3. Now here I'm going to realize these operations. Here will be 2 times x plus 6 minus 7. This would be equal to 2 times 6 minus 1. This would be just the same as g of h of x, which is in here. Now, let's get to the next level here. I'm going to realize what's in here, f of g of h of x. Let's get, now I'm going to write in here, I'm going to place this statement inside the f of x. It will be 2 times x minus 1. And this would be equal to, I'm going to substitute 2 times x minus 1 in every x of f. And here, plus 9, be 2 times x minus 1. And I'm going to solve this out. It will be equal to negative 8 times x plus 4 plus 9. And we get as a result negative 8 times x plus 13. It is too ugly. Like here. And this is just the result of f composed of g composed of h, or in other words, f of g of h. Now, let's get to this other statement here, which is f composed of g composed of h. Now, what I'm going to do here, I'm going to start, I'm not writing what's its equivalence, because first I want you to think it through during the procedure. I'm going to start by solving out this one here. So I'm going to write it in here. It will be f of g of x, like this. That is to say, I'm going to write inside this parenthesis 2 times x minus 7, and that is to say, I'm going to substitute in every x of f the value 2 times x minus 7, which is, I'm going to place it in here. I'm going to solve this out. Negative 8 times x plus 28 plus 9. This is actually an example we already solved in the past exercise. I'm just going to do it quickly, like this. And this would be equivalent to f of g of x. I'm just going to give here a different name to this function here. I'm going to call it fg of x. And this one will be fg of x. Now I'm going to, this statement here is just the same as saying this. I'm going to write it in here. Fg composed of h, which is just the same as saying fg fg of h of x. So I'm going to substitute the value of h of x for the values of fg, for the function of fg, I'm sorry. Now here I'm going to place it, x plus 3, and now I'm going to substitute it. I'm going to write it down here just to save space. It would be fg is equal to negative, fg is this statement here. I'm going to write it in here, x, I'm going to leave this space here, plus 37. I'm going to place here the value of x plus 3, which is h. Now I'm going to solve this out here. It will be negative 8 times x minus 24 plus 37. And we get here that it is negative 8 times x plus 13. And, well, surprisingly or not, this statement here is just the same as the result we got from the past exercise here. What is it to say that this statement here is just the same as this one here? So I can pretty much, rewrite. I'm going to actually copy this because it's exactly the same thing. Here, yes, fg composed of g composed of h is just the same as f composed of g composed of h, which is actually it sounds pretty similar. And so I'm just going to write it in the middle here in the center of this the screen to say f composed of the composed of g composed h is just the same as f composed of g composed with h, which in other words it's the what is called the associative property of function composition, which is a pretty nice property of this this topic here. Okay, this is the end of this example here. Hopefully it was useful to you. Let's move to something else.